Something that's not discussed too frequently in your book, in fact, I'm not sure it's there at all, but it is a lab we would be doing, is finding the molar mass of a gas, or technically a vapor, because you'd be starting with a substance which is a liquid at room temperature, but becomes a vapor at less than 100 degrees Celsius. And to do this sort of experiment, which we can't do, you would put about 5 milliliters of a liquid that I knew the identity of in an Erlenmeyer flask. We'd put a foil cap on the Erlenmeyer flask, and then you would place the Erlenmeyer flask in a beaker of boiling water. That would turn the vapor, or the liquid, into vapor at 100 degrees Celsius. You take it out. You would weigh the Erlenmeyer flask after drying the outside of it. And the mass, the difference between the empty flask, or the flask plus air, and the mass with the condensate in it, would be the mass of just the vapor at 100 degrees Celsius. It's a quick lab, we always do it, and we're not this time. But let's take a look at some data you might use. First of all, we'd start with the ideal gas equation, PV equals nRT. And we could rearrange this to solve for N. PV over RT equals N. N is the number of moles, and N can be found by taking the mass of a gas, or the mass of anything in grams, and dividing by the molar mass. Okay, this is going to give you units of grams divided by grams per mole, which is going to give you moles. Okay, so we're going to make a substitution in a bit for N using these units. So we have PV over RT equals grams over the molar mass. Okay, mm's just going to stand for molar mass. You guys good with that? Now, if I want to solve for the molar mass, I'm going to bring it to this side of the equation, and I'm going to bring all of these guys over. So I have molar mass equals grams times RT over PV. So if we were doing that experiment I was talking about, grams would be the mass of the condensate after you'd finished heating it in the Erlenmeyer flask. R is R. T is the temperature at which you had the gas, which is 100 degrees Celsius, the boiling point of water, or 373 Kelvin. Pressure is 1 atmosphere because we're at sea level, and V is the volume of the flask. So let's do a problem. So for this particular problem, you have a volume of 0.200 liters. Okay, a little bit, kind of an odd size, 200 milliliters for an Erlenmeyer flask. The mass of the gas that you would determine is 0.4 grams. That would be the difference between the empty flask and the flask plus the condensed vapor. Your temperature would be the boiling point of water, which is 373 Kelvin or 100 Celsius. R is the gas constant, which equals 0.0821 liter atmospheres per mole Kelvin. And the pressure, because we happen to be very close to sea level at SJ, is 1 atmosphere. You plug it into this equation right here. So the mass is in grams. Okay, so we have molar mass equals grams. And I look at the equation, I have 0.4 grams times R, 0.0821. I'm leaving the units out this time. Temperature is 373 Kelvin. It's not room temperature because you wouldn't have a gas at room temperature, you'd have a liquid. The pressure is 1 atmosphere. And the volume is the volume of the Erlenmeyer flask, 0.200 liters. So we're going to multiply these top three together, divide by the bottom two, and the molar mass of this gas would be 61.2 grams per mole. This equation and this setup here, this data here, is going to be very important for the final exam. So make a note of that.